Okay, hello guys. We're going to talk about the domain or finding the domain of functions in equation form. So let's go ahead and define domain when it comes to, a function in an equation form. So let's say, for example, you have a function of x, which is equal to 2x plus 3. So remember now that, okay, by definition, the domain of a function is a set of all real values of x that will give real values for y. And the range of a function is a set of all real values of y that you can get by plugging real numbers into x. Okay, now because 2x plus 3 falls under a polynomial equation, or it is a polynomial equation, the domain of this is going to be all real numbers. Okay, so the domain of all polynomial equations is all real numbers. Why? Because if you have a line, okay, so this line will hit every single x because it's going to continuously go from go on both direction, so pretty much it will hit every single x um, value. And even if it's not a line, even if it's a parabola, like for example f of x you know is equal to 2x squared minus 1. So how do we know that it is a parabola? Because the highest exponent is 2, so it is a quadratic equation. And this is a line because the highest exponent of x is 1. So we know that that's the line. And here the highest exponent is 2, so it should be a parabola, either opening upwards or opening downwards. So let's say this, because this is positive, so it is opening upwards. So this is a parabola that will keep going on both directions, to the left and to the right. So these two are actually both, well, functions with the domain where the domain is all real numbers. So we're going to say that the domain of this function is all real numbers. Okay, and then here we're also going to say it's all real numbers. Okay, now remember that all real numbers in interval notation is from negative infinity to positive infinity enclosed by parentheses. So we're going to use the interval notation to express our domain. Okay, now going back to the fact that the domain of all polynomial equations is all real numbers, let's extend our examples to, okay, I'm going to say this is example 1, this is example 2, and this is example 3. Okay, let's extend our example to the third function that we studied earlier, the h of r is equal to r to the third power minus 2 r squared plus 5. So because it is to the third power, even though it's the third power, it's still a polynomial equation. And how do we know a polynomial equation? There's no fraction, or there's no variable in the denominator. It's pretty much all the variables are just in the numerator. So this is a polynomial equation. Therefore, we're going to say that the domain of this is also all real numbers. And even if it's to the fourth or to the fifth, let's say, for example, number 4. Okay, I'm just gonna say g of x is equal to 3x to the fourth minus 2x to the third plus 5. Because it's still a polynomial equation, the domain is still going to be all real numbers. Okay, now the question is, when is it going to be not all real numbers? And we'll discuss that in the next video.